Hi guys, so for today's lesson we're going to be dealing with fractional indices. So some rules to remember. So fractional indices are powers that are a fraction and they have the ability to change to a root sign. So the general rule is this. So if you've got some sort of base, A, that is powered to a fraction. So this x and y is our fraction. They literally could be any numbers in our fraction. That can change to this form. So you'll notice that your base of A goes underneath a root sign. The y tells you what type of root it is. It could be the square root or the cube root or the fourth root or the fifth root or the sixth root, etc. So that's indicated by the y. And the x, the numerator, is powering that base. Notice that that x could also be outside the root sign, powering the whole lot. It doesn't matter. The x can go from here or outside. Okay, so a big note is that when the y value is even, so when our denominator is an even value, the a or our base must be greater than 0. It must be positive. And the reason is that, for example, you can't take the square root. So, for example, when the y is equal to 2, that's the square root of a negative number. Like it's just error. You can't do it. But you can take the cube root of a negative number. So the cube root is when our y is equal to 3. So if you're, so pretty much if this y is odd, you can take the cube, like you are allowed to have a as a negative number because you can take the cube root of a negative number. But if this y here, if that's even, it pretty much means that this base here has to be positive. Otherwise, it'll give you an error in your calculator. Okay, so let's try some examples with these fractional powers. So 5 to the power of 3 over 4. You'll notice that your y is even, but your base is positive, so it's okay. If that was if we were doing like a negative 5 here, it wouldn't work because our a has to be positive when we're dealing with an even value of y, or we're dealing with the fourth root. So this denominator of 4 tells you what the square root, what type of root sign we're using. We're dealing with the fourth root, and the 3 up the top powers our base of 5. So we've got the fourth root of 5 to the power of 3, and 5 to the power of 3 can simplify to 125. 5 times 5 times 5. Okay, e.g. 2, let's try another. X to the power of 1 over 6. So the 6 tells us that it's the sixth root, and the 1 up the top powers the base of x, and x to the power of 1 is just x. So the rule of thumb is when you have a 1 up the top, in your final simplification you won't need to show the 1 because x to the power of that 1 is just going to be x by itself. Next one is a to the power of 8 over 1. So we do have a fraction here, but 8 over 1 is the same as just a regular 8. So when you've got 1 as the denominator, you won't need a root sign because it's just going to be a whole power of 8. This one here, y to the power of 3 over 2. The 3 definitely still powers the y, but the denominator of 2 doesn't have to be shown because this root sign, if it doesn't have a number here, it is implying that it's a 2. So we could choose to put a 2 right there, but there'd be no point. It's actually simpler if we don't show it. So pretty much we don't have to show it when there's a denominator of 2, but we do need to show it for other numbers like 4 and 6 and 3 and 5, etc. Okay, let's do some harder examples. So let's simplify the following here. I look at this question and I see a negative power and I see a fractional power. So I want to try and remove both of these things. So the negative power can be removed by taking the reciprocal of our fraction. So remember that stuff that's negative powered goes from top to bottom or bottom to top. And we can get rid of the fractional power by using a root sign. Okay, so let's take the negative of our fraction first. So 4 over 9 changes to 9 over 4. Now, our negative power becomes its positive version. Now, I look at this. I see a power of 3 and a power of 2 down the bottom. When we have a power of 2 down the bottom, that indicates the square root sign, just like up here. So that means that we can firstly apply the square root to 9 over 4. So 9 over 4 are both square numbers. If we apply the square root to both of these numbers, 9 changes to 3 and 4 changes to 2. So pretty much I can apply the denominator of 2 by taking a square root. Just like I did here, like I could apply this power of 2 by taking the square root. And then I can now apply the 3 to the y. Okay, so now we apply the top number of 3. So we can pretty much power this fraction to the power of 3. 3 to the power of 3 is 27. And 2 to the power of 3 is 8. So we get 27 over 8. So it's handy to do these sorts of questions by just considering the denominator, then considering the numerator. Let's try another one. So x to the power of minus 4 over 5. Again, we can change the negative. We can apply the negative power to x by converting x to its reciprocal, and then the negative power changes to its positive version. Now, when you're powering 1 to the power of anything is going to stay 1. So 1 doesn't change no matter what the power. And then we apply the 4 over 5 to the x. So we get x to the power of 4 and 5. And then we definitely want to change this fractional power to its root sign. So the 5 goes out the front. So it's the fifth root. And the numerator of 4 is powering the x. So we get 1 over the fifth root of x to the power of 4. Lastly, we've got this one here. We've got two powers with a base of x, and they're dividing. So whenever you are dividing things with powers and they've got the same base, you can subtract the powers. So we're going to be having negative 7 take away 2.5, negative 2.5. So negative 7 take away negative 2.5. You'll see when we're taking away a negative, we get the double negative. So negative 7 plus 2.5 gives you negative 4.5. Now we've got a mixed numeral here as a fraction. As a power. We definitely want to change that to its improper fraction. We don't want to deal with mixed numerals. I'm going to apply the negative to our power to our x, which converts it to its reciprocal. The positive version of the power comes down, and we get the 2 is taking the so we're going to apply this to top and bottom, and 1 to the power of anything stays 1, and the x is powered to 9 over 2, so that comes down here. The 2 indicates the square root, and the 9 powers the x underneath, and we get a final answer of 1 over the square root of x to the power of 9. So they do take a bit of time and some practice, but you'll get there. Good luck with the questions.